Alright, this is the fourth video in the factoring set. Remember that our first video was all about the GCF. The second video talked about the sum and difference of squares. And the third video spoke about standard form when a was equal to 1. What we are dealing with here is now that a is not equal to 1. Looking here, I see that I have 5x squared minus 13x plus 6. I want to remind people that our first job is to look for a GCF. In this particular case, I'm not going to find one because this back term does not have a variable, and 5 will not divide evenly into 6, neither will any of the factors of 5, basically 1 or 5. So this has no GCF. In the other videos, we looked at a situation where we had to go in reverse, and again, reminding you all that factoring is simply unmultiplying, or going from the products back to the factors. That's what we're aiming to do. So, looking at this particular example here, this is a review. So, if we were to look for a GCF, we would see that the GCF here is 4. Then I would have a common factor of 4, which then would be multiplied to x squared minus 5x minus 14. What I was doing in the last video, we would then factor apart the c value. So we would take this value here and factor it apart here. So I had 14 was 1 and 14 and 2 and 3. Sorry, 2 and 3, 2 and 7. 2 and 7. Then what I would do, my next step would be to determine that I needed to subtract to make -5. I was subtracting to make the b. After that, I would write my two binomials. So we would determine that 2 minus 7 would equal to -5. We would identify that these two numbers were the set I needed to use, so therefore I would have x plus 2, x minus 7 with a greatest common factor of 4. And this was complete. So essentially we had step 2 happening here. We had step 3 happening in this area. And then we had step 4 happening where I wrote my binomials. The reason why I brought up this example is because we are going to add a few extra steps when we have no GCF and our a value is still not 1. So we have several steps here, and we will recognize some of them. Step 2 is factoring the value. Step 3 is choosing to make the b, and step 4 is writing the binomials. The new steps are in blue. So in this particular case, what our job is to do is to multiply a times c, and we're going to ignore the signs. Apply a times c. My a value is 5, just the 5. And I'm going to multiply it to the c. We're going to write that result on the side here. So that is going to be 30. This is in fact the value that I'm going to then factor apart. So on the first example, I would simply take the c value only, but here I have the product of a multiplied to c. That's what I need to factor apart. So in this case, I have 1 times 30, 2 times 15, I have 3 times 10, 4 doesn't work, but I have 5 times 6. So again, we're kind of back on track. What we notice next is that we should add to make negative 13. This process is exactly the same. So here I have to add values, and if I were to add 3 plus 10, I would equal to a positive 13. That's not the values I want. So what I'm going to do is I'm going to use negative 3 plus negative 10, and this will equal negative 13. That is the set of numbers that I actually am needing to complete this particular problem. Ran out of space. And then I'm going to write my two binomials just like before. The two binomials are going to use x minus 3 and x minus 10. What I need to point out is this expression here will not produce the one above. It is not complete. Partly the reason is that I've multiplied the 5 times the 6 and created the 30. Since I've done that, I have to undo that. So to counteract the multiplication, I'm actually going to divide just the back terms by the 5, or by the a. So I've multiplied by the 5, I now divide the 5 off. But I only do it to the variable, or to the constants in the back of the binomials. That's step 5. Now step 6 is reduce and rearrange. What this means is each of these fractions need to be reduced if possible. This fraction doesn't reduce. It stays as negative 3/5. And this is only the first part. This fraction will reduce. This becomes negative 2. This part looks our typical binomial. This part has an odd fraction in it, so we are going to rearrange. In short, what that means is we're going to take this denominator here and swing it up and park it in front of the x. That's where it's going to live. So now we have 5x minus 3 multiplied to x minus 2. And we are complete here. So it's a little more work in this particular case, but we are finished. All right? If we're going to check our which I highly, highly recommend, we would check it by multiplication. So if I check, what I'm going to do is take the 5x minus the 3. I'm going to multiply it to x minus 2. I'm going to multiply this, and I will have 5x squared. I will multiply here, and I will end up with negative 10x. I will multiply underneath, which will give me negative 3x. And to finish off this problem, at least the multiplication part, I will multiply here, which will give me negative 6. Now I need to combine my like terms. This gives me my negative 13x. The minus 6 lives in the back, and the 5x remains in the front. I see that my product here derived from my factors matches exactly the product that I started with. So we are good. So what we had before, when our a was equal to 1, we had these same interior 3 steps. All we've done is we've added a multiplying a to c, and we ignore the sign. We would divide by the a that we've just multiplied by, and then we will reduce and rearrange. And this allows us to factor when a does not equal to 1. Let's try this again. Here's an example. So, first step. We're going to multiply a times c, and we're going to, actually, first step here, I should speak, is to, first we need to look for a GCF. Again, that's always. So is there a GCF? All right. Looking here, it looks like I'm able to divide by the 4, except I notice this doesn't divide by 4, so let me back up. And what I'm going to do is instead divide by factors of 4. So I know that, oops, too much. I know I can divide by 2, by 2, and by 2. I have a GCF of 2. On the inside, 24 divided by 2 is going to give me 12x squared. 22 divided by 2 should give me 11x. And 4 divided by 2 will give me a 2. So now that we've taken the GCF out, on the interior of this, we see we have 12x squared plus 11x plus 2. This is a standard form quadratic a, b, c, but the a does not equal 1. That's different from the last video. So our steps change only slightly. Again, remember, the 3 following steps, step 2, step 3, step 4, are the same, but this first step is a little bit different. What I'm going to do, just on the interior, I'm going to multiply my a to the c, and I'm going to ignore the signs. So just 12 times 2, this is going to be equal to 24. This is the value that I am going to factor apart according to the next step. So when I factor 24, I will have 1 multiplied to 24. I will have 2 multiplied to 12, 3, 8, 4 multiplied to 6, 5 doesn't work, and that's the only set, or that's the only number left between 4 and 6. Next step, I'm going to choose to add or subtract and make b. In this particular case, notice the symbol I'm looking at? This tells me I need to add to make the b. Now in this case, b is going to be a positive 11. So one of these sets of numbers is hopefully going to add and give me positive 11. Well, if I look right here, I see that 3 plus 8 actually will be 11. So I'm going to use in the binomial, set up the binomials. For my binomials, I will set up the x is in the front, the x is in the front. I will have a positive 3 and a positive 8. Now it goes back to being a little bit different. Step 5, divide by the a. This is necessary to undo the work that I did here. I multiplied by 12. So in this case, what I need to do is actually divide by that same 12. This part's complete. What I need next to do is to reduce and rearrange. So this fraction here actually will reduce. Both the top and the bottom could divide by 4. So this will actually become 2/3 plus x. I'm going to leave it inside its binomial temporarily. This will actually reduce to 1/4 plus x. And again, I'm just reducing it. Then what I'm going to do is to rearrange. What the rearranging says is that this 4 should become the coefficient on this particular x, leaving for us 4x plus 1. This is my first factor. This 3 actually needs to live in front of this x, becoming a coefficient, 3x plus 2. I need to not forget that there was a GCF. This GCF will come all the way, include the GCF, to park itself in front, and this then is the finished factor set for the original problem above. We can check this on the calculator. Remember that we will enter the first or the original problem into the y1. This is from the previous video, and the completed set of factors in for y2. So to clear both of these, and then I'm going to type the original. This is the 24x squared plus 22x plus 4. So carefully watching what I'm typing in. 24x squared plus 22x plus 4. Now, I'm going to type the complete set of factors, which is 2 as the greatest common factor. Then I have 4x plus 1. Close that first set of parentheses, finish off that factor, open up the next one, and type the 3x plus the 2. Close it. What I'm going to do is I'm going to look at the table of values, and my y2s and my y1s are matched identically. This is confirmation that we have factored it correctly, that we made two equivalent expressions. This is going to take some practice. So let's try one more. This one here is a little bit different because I noticed something off the bat. First, there is no GCF, so I don't have to. But I do see the pattern of that we talked about in a previous video, x squared, x, no x. I see the coming from the back, the y squared, y, no y. In this particular case, what we recommended previous is to first write without the y's. So what I'm going to do, I'm going to just copy this problem over on the side and just ignore the y's temporarily. 2x squared minus 3x minus 20. What I will then do is to factor, and then lastly, the y's need to be placed. We're going to place them in the back of the two binomials. So we've kind of pretended that they aren't there. When we're finished, the pattern will work regardless if they are there or not. We're going to park the letter y here and the letter y here. Right in front of the y are going to be the two factors that we pick that will complete our process. So what we are looking at here is an altered version, a y-less version of a standard form with a not equal to 1. So what we must do with this problem is to go ahead and multiply the a to the c. I'm going to take this A, I'm going to multiply it to this C, and we're going to record the number here. That's going to give us 40. We're going to factor then we're going to factor that number. So we have 1 and 40. I'm actually going to pause for a sec. I was running short on space, so I just rearranged a few things to give us a little more space. So 1 and 40, 2 and 20. 3 won't work. 4 will, giving us 4 and 10, 5 and 8. And the only numbers between 5 and 8 are 6 and 7, and they do not produce any factors that are integer factors of 40. So we have completed this. The third step is going to be choose how we make the b value. Well, as always, we're going to look at this back sign, and we know we're going to subtract to make -3. I'm looking at my factors, and I see that if I were to use the 5 and the 8, 5 minus 8 does equal -3. So the numbers I'm going to park into my binomials are going to be the +5 and the -8. Needed to move a little bit here. So we found that we have 5 minus 8 gives -3. What I'm going to do then is to continue with my process where I'm writing the two binomials. And again, I'm not yet ready to go back and replace the y's. So I have x plus the 5, and we have x minus the 8. So the next step is going to be divide by the a. Remember, at the very beginning of this problem, we multiplied 2 to the value of c in order to make 40. This is just a number set that we are working with. Then what we must do is we have to undo that multiplication by a. So we're going to divide by 2, we're going to divide by 2. We're going to reduce and rearrange. So this factor, or this fraction, I'm sorry, will not reduce, and I'm going to leave it as 5 over 2 plus the x in the first binomial. Here, this will actually reduce to make the value of 4 in the second binomial factor. Then the rearranging part will move this net 2 up in front of the x so that I have a coefficient of 2 here. So what I will end up with is 2x plus the 5. And then I will end up with the second factor of x minus 4. Now, we're ready to put the y's back in, so this part is written here to make 2x plus 5y, and then I'll have x minus 4y. This would be the completed set of factors here, and we would be finished. We should check, and if we did check, we would see this. I paused the video to save some time and wrote the result. You can see that I've written the two factors here. I've FOILed them or double distributed them and got the product here, which then does match my original. This one cannot be done on the calculator because I do have this back value of y. You can't check it completely. You could check just the x part, but you can't check the entire thing. All right. We do have a next section where we're actually solving with this. This video has gone on a little bit long, and so I want to go ahead and stop this video, but there is a part 2 where we're actually solving when our a does not equal 1. And it's going to be similar to before. I'm going to pause this, I'm going to stop this video, we're going to pick up here on part 2 of this.